All right, so it turns out this is part 2 of my video on extreme values of functions. All right, part 1, I introduced some of the terminology and I did some examples. I decided to continue that here, so this is not the place to start for this topic. You need to start with part 1, but you should be able to find part 1. And I want to start with this one, okay? So there's this curve, right? That's a function, that's a curve, that's something that you could draw the graph of, however you want to think about it. I'll look at it on this window right here. All right, what's that? What do I mean by that window? That's a finite portion of this curve. It's not the whole thing. In other words, this is like saying I'm going to look across the x-axis from about 0 to 6. 2 pi is a little bit more than 6. I'm only going to see this part of that graph, and I want to find the points that are the absolute highest points or the absolute lowest points. Okay, so that's what it's asking us. Now, I outlined a procedure before about doing that, and the first step on that procedure was to find the critical numbers. Okay, so critical numbers are points on the curve where the derivative is either 0 or undefined. So we start by at least finding the derivative, and then we can go about solving for it to be 0 or undefined. So the derivative of this, 5 cosine x, is 5, well, the derivative of cosine is negative sine, so 5 times negative sine x, or negative 5 sine x. Okay. So there's our derivative. Now, this will never be undefined, okay? That's just the nature of the sine function. Anytime you take sine of a number, you get an answer. So it's never undefined. You always get an answer. But what about that derivative being 0? Well, that's going to amount to solving negative 5 sine x equals 0. If we divide both sides by negative 5, it'll amount to solving sine x is 0. 0 divided by negative 5 is 0. Okay, so here we have to, unfortunately, is no nice way to do it. We have to think about the angles where sine of the angle is 0 in the interval from from 0 to 2 pi. Okay, so sine is 0 for any angle coterminal or with any angle that puts you on the x-axis. Okay, any angle that's coterminal with either 0 degrees or 180 degrees. Okay, so in my case, like this would happen at x equals 0, x equals pi radians, that's the same as 180 degrees, or 2 pi or onward, so like 0 degrees, 180 degrees, 360 degrees. Those are the angles that have a sine of 0, okay? Now, that's a whole other topic from pre-calculus that we could talk about if we needed to, but that's what I need to tell you for now. Now, only one of these numbers is in play. Only one of these is in the interval, and it's pi, okay? So that's our only critical number. And it's not real, it's not like technical math speak to say in play, but you know what I mean, okay? All right, so pi is my critical number. Now, let's look at the points on the curve and make a comparison. All I need to do to find the absolute highest and lowest points of this curve on that window is to compare the left endpoint of my window, the right endpoint of my window, with the critical number. Okay, this is the left endpoint. That's the right endpoint. That's the critical number. And I want to find the actual points on the curve. I don't use the derivative for that. I use this. F of x is 5 cosine x. Okay, so we'll do the math here. So what's 0 give you? 5 times, or cosine of 0 is 1 times 5 is 5. Cosine of pi is -1. I get -5. And then cosine of 2 pi, well, same thing as cosine of 0, that's going to be 1, so this is also 5. Okay, so I'm seeing on that window, starts at 5, dips down to -5, rises back up to 5. Looks something like this. Okay, here's our curve on our window right here. So there is the curve. F of x is 5 cosine x. This point, 2 pi for x, 5 for y. This point, 0 for x, 5 for y. This point, pi for x, -5 for y. That's what it looks like, okay? And that gives us our answer. If it looks like this, then I know the absolute maximum would not be this one or that one, it'd be both of them, okay? So we'll say absolute maximum, the point 0 and 5, and because this one is on the level with that one, it's at the same y coordinate, they're at the same height on the curve, they're both absolute maximums. It's going to be 2 pi and 5. Okay, so those are the maximums. And then the absolute minimum is this one. That's below all the others. So that's going to be pi and -5. Okay, and we're done with that one. Okay, only tricky point might be, well, I won't say the only, but you have to, know some stuff you learned in pre-calculus to solve this. Okay, all right. So, but otherwise, I did this with the same procedure that I've used for other problems so far. Okay, all right. So say we got that. Let's look at this one. Okay, find the absolute extrema, meaning the absolute maximum and minimum of this curve on that interval. Now with this one, I'm taking a different approach. Okay, it's not a typical problem. I mean, it's one that we can learn to do. It's not off limits or anything, but it's not a typical problem to find the absolute value of, or the derivative of something with absolute value in it. Okay, so here's my way of approaching this one. I just sketched it because that's an easy enough graph to draw. It's based on just the absolute value graph. It has a horizontal translation, a vertical translation, and a reflection. But if you plot enough points, this one's not that hard to do. Okay? So here I plotted enough points to sketch it, and that's what it looks like. This point right here, this is 1 for x and 1 for y. Okay? And this point is 5 for x. Okay, so 5 minus 1, that's 4. That's -3 for y. And this point right here is -9. Remember, that's the far left edge of our interval. -9, -10, so -9 for y. Okay. So there it is. Now, if we could just graph it, then look, that's the absolute maximum, that's the absolute minimum. You see? I mean, if we had the graph, then we have the answer as far as that goes. When I do other problems, like, so for example, when I did this one, I'm just trying to see what that graph looks like by finding the critical number and comparing to the endpoints. It tells me the basic shape of it. But I don't have to go through and graph it with a bunch of points to figure that out. I just need 3 points, the endpoints and the critical number, okay? With this one, I went ahead and graphed it. Here's why. Because it's finding the derivative of the absolute value is not something I want to address at this moment. I will tell you this, though. On the absolute value curve, there is a corner point, okay? So, at that corner, y prime is undefined. There's no way for me to tell you the slope there, or there's no way for anybody to tell the slope there because it's a corner. So that is a corner point. Any graph that has a corner point is going to have the derivative undefined at that point. Okay? So that means that on this one, because it looks like this, because that is in fact a corner point. It's not smooth right there. It doesn't like dip downward or upward in an arc. Okay, then the derivative is undefined, and 1 for x is a critical number. Okay, all right, so I wanted to tell you that we can do this problem this way. Get graph paper out, plot points. It's going to have a V shape to it because it's based on the graph y equals absolute value of x. Okay, so it's with some perseverance, I know you can graph that, and you can tell me that at the corner the derivative is going to be undefined. Now my final answer then, given that I'm now looking at it, I can see it right in front of me, is that that's the absolute minimum and that's the absolute maximum. Before, you know, when I did other problems, take any problem you want, but when I took this one, this table right here is just allowing me to see the points on the graph. Well, now the graph's right in front of me. I don't need the table. So let's say this. We'll say absolute minimum. That would definitely be this one. -9 for x, -9 for y. And then the absolute maximum. That would be that one. 1 for x, and if you put 1 for x, you'll get 1 for y. Okay. There, so mainly I do that one to tell you about one way that the derivative being undefined and what that means. Okay? All right. I haven't told you the whole story about the derivative being undefined, but at least at a corner point on an absolute value graph, then it will be. All right, so you know that much so far. There's still, unfortunately, more for me to tell you, but that's what I can establish at this point. Okay, so let's do maybe like a little review then. Okay, so, all right, now, so let's take this curve right here, say that point is point x is equal to c. That point's a minimum, and that means that this is also a critical number, right? F prime c is 0. So that's why we find critical numbers. If the slope was 0, that's a spot where it could dip down to a low point, okay? And take this curve. What did we just say about corner points? So you said that point right there, that corner right there at the top, that's x is equal to c. Well, that's undefined for the derivative. F prime c is undefined. But that point's a maximum. So this point's a minimum, that point's a maximum. In both cases, the number c is a critical number. All right? So what we look at is that we draw this conclusion. If a curve has a maximum or a minimum, then the x value at that point must be a critical number. All right, that's true. That's why we start our procedure every time by finding the critical numbers, and then we put them on the table and compare. But, however, just because there's some point on a curve that is a critical number, like right there, see this curve? Right there, it's perfectly flat. Just like right here, it's perfectly flat. But at that spot, there is not a max or a min, okay? Even though f prime c is equal to 0. So my point in telling you that is that just because you find a critical number when you do your math doesn't mean that you actually determine that there is a maximum or minimum at that point, okay? So in order my illustration of that, I'll show you this one. Okay. So let's do this. Let's say find the absolute extrema of the 9th root of x on the interval from -1 to 1. I could, if it was convenient for me to do calculations that way, I could leave it. If I wanted to, I could say this was x to the 1/9 power. It doesn't matter, all right. So, but either way, let's start by finding the critical numbers. All right, so we find the derivative. Okay, and I get 1/9 x to the -8/9 power. There's your derivative. And writing that a little bit different, And I might put it like this. Okay. Now, what's a critical number? A critical number is a point on the curve where the derivative is either 0 or undefined. This will never be 0. 1 divided by some other number is never going to be 0. Okay? So as far as this goes, I might say f prime x being 0 is not possible. Okay? What's the other case again? Well, so critical number is a point where the derivative is 0 or undefined. Well, could this be undefined? Well, it's undefined if you divide by 0. Okay? So we'll say, well, about that, look at that. Undefined if x is equal to 0, because 0 to the 8/9 power is 0, times 9 is 0, and 1 divided by 0, ultimately that's undefined. So there's our critical number. All right. So something might be happening there. It might be that there's a high point or a low point. Or it might be that nothing happens there. Okay? But we have to consider it. All right, so 2, we make our table. Okay. What do we put on our table? Well, we're looking at actual points. So let's see, here's x. What was the equation of my curve? It was 9th root of x, okay. 9th root of x. And I take the endpoints in my interval, -1 and 1, and I compare with the critical number. So that's the left endpoint, that's the right endpoint. Here's the critical number. We'll do a little bit of math from here. What is the 9th root of -1? It's -1. Why is that? Well, -1 to the 9th power is -1. What's the 9th root of 0? 0. 9th root of 1, 1. So there we go. Okay. Well, what's that look like? That's the lowest, that's the highest. The maximum and minimum are at the endpoints. What would this curve look like if, as I scanned it from -1 to 1, it started down at 1 and it rose up to 1? Something like this. Okay, this is what we see. This point is 1 and 1. That point right there, 0 and 0 in the middle. And this point is -1 and 1. Okay, -1 and -1, sorry. All right, that's what we see on our window. This curve on that window looks like this. All right, well, there's the maximum. Here's the minimum. Absolute maximum, 1 and 1. 1 for x, 1 for y. This point right here. And then the absolute minimum, -1 for x, -1 for y. This point right here. All right. The critical number, though, it needed to be on our table because we have to check, didn't end up being where the max and min is. So it's like, our graphs in general can be like this, or they can be like that, or they can be like that. Okay. All right. This one is like that third option down there. Okay. So let's look at, let's do this one. Okay. All right. So, and this will be my last one of this kind. But I did a little something different to go along with my work, but it's, other than that, I'll try to think about it and work it the same way as the others. Find the absolute extrema of this function on that interval, 9 to 13. So I think to do this, a person would have to know a little bit about graphs already, okay? And I'm not saying that that you have this perfect image in your head of what that graph looks like. But we should have some basic concepts of what graphs look like. Okay, very basic concepts. We should get to the point where we know that absolute value graphs look something like this, and that we could plot points if we needed to get more detail. We should have basic ideas like that. So this one, it's a basic idea that you might learn about this when you take algebra, is that curve, that function, has a vertical asymptote at 8, where the denominator is 0, and it has a horizontal asymptote at y is equal to 1, which is the quotient of those leading coefficients, 1x and 1x. Okay, but that is another story. If we needed to review algebra, that's something we have to do separately. But I went ahead and I sketched it. All right, here's my horizontal asymptote, this horizontal line at 1. Here's my vertical asymptote, this vertical line at 8. And in red pen there, you see the graph. I made a little bit of a table. I plotted some points. I sketched it. It looks like that. Okay? What I want you to notice about this one is that, well, to look at that window on this curve, we're looking in here. Okay? All right, now I know on other problems I did not start by drawing the graph in this much detail, but I want you to know that the graph is out there, and then we're just asked to see some specific information about it in each problem, okay? So yeah, we're looking like 8 right there is where this vertical asymptote is, and then we're looking at it from 9 to 13. Well, so that's like just the part in here, okay? Now, all right, I can tell you the answer at this point. That will be the absolute maximum, and that will be the minimum. They're going to occur at the endpoints of this interval, all right? Okay, but nonetheless, let's practice the rest of it, all right? This little prediction of the answer, that's the big picture. So 1, what's the critical number? Okay, well, that's the points where y prime is either 0 or undefined. So let's look at this as y, and we use the quotient rule to find y prime. So y is equal to x over x minus 8. We get f prime times g minus g prime times f. And we get like that, okay. And then we get x minus 8 minus x over x minus 8 squared. And so this ends up being just negative 8 over x minus 8 squared. All right. So there's my y prime. That's how I'll find my critical number. What is a critical number? It's a point where the derivative is either 0 or undefined. Well, you know, if I have negative 8 on top, that will never be 0. Negative 8 divided by any other number is never going to be 0. Okay? So y prime will never be 0. Could it be undefined? Y prime is undefined at 8 because you're dividing by 0 if x is equal to 8. Okay? Why is y prime undefined at 8? Well, is it because, what have we seen so far? Is it because there's a corner point? Is that why it's undefined? That's one feature on a curve that could cause the derivative to be undefined. It's a corner point. Is that why this one is undefined? At 8? No, this one is undefined at 8 because the graph is not continuous at 8. It's got this vertical asymptote, and it's where there's this gap where the graph does not connect to itself across that line. Okay, that's the reason. But still, it's undefined at 8. So I guess 8 would be a critical number. Is it a critical number in play? Well, our interval is 9 to 13, so in this case, that is a critical number, but it's not in play this time. Okay. Well, what are we going to put on our table? When we do our table, what are we supposed to put? When we make this table and we compare and we find the maximum and minimum, first I put a column for x, then I put a column for y. I put the left endpoint, right endpoint, and critical number, and at least this time, the critical number is not applicable. There isn't one. There's not a critical number on this curve in the window that we're looking. All right. So, but my left endpoint's 9 and the right one's 13. I just have to compare between those. Because I took the time to draw such an accurate picture, that's going to be the bigger number and that's going to be the smaller. But let's complete the table, do the math, and see. All right, there's the table. So just like I was thinking, 9 and 2.6. This points at 9, and that points at 2.6. This one being a lot higher up than that one, okay? Now, normally at this point, I draw a little sketch of what we're seeing on our viewing window, but that's already right here. This point right there, 9 for x, 9 for y. And this point right here, 13 for x, 2.6 for y, okay? All right, let's give a statement of our answer. Absolute maximum. 9 for x, 9 for y. And then our absolute minimum, that would be this one, 2.6 being smaller, lower down than 9. 13 for x, and I'll go ahead and I'll put 13 fifths for y.